We're going to be building a simple API that allows you to sell AI to anyone you want. First off, you're going to want to say pip install. You already have Python. Most everyone these days has Python installed on their system. You've got Python on your computer, Windows, Mac, Linux. Usually comes pre-installed with Python. If not, you want to go to the Python website, download Python interpreter and runtime, and the package manager pip as well. Pip install FastAPI, and then press enter. You're good to go. Another common practice is to put that FastAPI into a requirements file. So you could say echo FastAPI into the requirements.txt. Then you want to git init, so that way you have a repository. If you don't have git version control, add that as well. It's worthwhile. Git add to add the files. Git status to show what hasn't been committed yet, and then git commit to commit a message saying added dependency. All right. Let's see here. Because I have never had a Python AI project not break after 6 months. Ever. That's a really good point. You're bringing up a good point. Okay. So you also might want to set up a virtual environment. So how do you say detach? Because I've already got one right now. Is it how to detach? I forgot. Because I have one main one that deactivate is what it's called there. So you say deactivate, and then you can create a virtual environment by simply typing in Python -m env. Let's see, just like that venv. There we go, virtual environment, and then you could create a .venv directory essentially. So you could do a virtual environment, so that way everything stays nice and tidy, all the packages. So you want to see pip install FastAPI. So that way you've got that. And I do believe, it says we could upgrade. Let's do the upgrade really quick. We're doing all these extra prerequisites. So if you run into any of these problems, this is what you could do as well. All right, so then you should consider upgrading via. Okay, I'm going to upgrade via this command. This very long command we're upgrading now. Hey, Mohammed, welcome on in. Happy Friday. Today we're doing how to make your own AI API. You'll be able to have an AI API server, and then you could sell the access to that server if so you wanted. So I've done this. You've done it the way you describe and got inconsistent, and since it was your base Conda, Conda environment. I know Conda, you're right. I have deleted that Conda. Like mini Conda, to use mini Conda, and all my VMs. That's the way to do it. Why FastAPI? FastAPI is really easy. It's super simple. It's clean, and it's really fast. So let's see. I do believe we have everything installed. So let's see. Pip install. So cat requirements. So we added a requirement file. Let's see here. What other options would you consider for this? Flask. So you can also do Flask. So let's open this up. So you could do FastAPI is the one we're doing today. And then you could also choose Flask Python, which is also another easy getting started option, right? It's another easy option. Let's see here. The syntax is not too much different. Minimal application. So you've got this, which is fine. It's great. Looks good. Have you heard about the new student that got 55,000 bill for his leaked API key? Oh, that's not good. That seems like a problem. Yeah, be careful. Your environments and all of your API keys, they could get leaked. And then you could have a problem. All right, so let's see. Learn. There is a quick start around here somewhere. Where is it? Tutorial. First steps. Here you go. Okay, versus this. All right. So you've got this syntax versus this syntax. I think they're both basically the same. They're both essentially the same thing. I like the FastAPI a little bit better because it doesn't have the Python underscore name, although I suppose you could do whatever you want here. With Hugging Face, be extremely careful about the version you make. Install it after your PyTorch. Oh, that's good to know. All right, so PyTorch first. Also, since PyTorch is GPU specific, you want to make sure you get the right one. That's a good point. That's a really good point. There's extra steps if you want to ensure that you have the right hardware accelerator. The software that goes along with it is specific, right? Every system is different. So are you using NVIDIA? Are you using AMD? Are you using I guess maybe Intel, or using a TPU or a, specific hardware ASIC, right, from Amazon or Google. There's a whole bunch of options out there. And so you got to pay attention. All right, so we can do pip install -r requirements. Make sure we've got everything there. We will only start with the FastAPI first. We're going to make it easy, and then we'll jump into the AI pieces. So we've got this part. So let's open a main.py file, and then we're going to say, I believe it's import FastAPI from FastAPI, something like that. App equals, I believe it's FastAPI, something like that. Or wait, I'm doing it. I think I'm doing this backwards. Oh, right. From FastAPI import. I forgot. Python's the opposite direction. All right, so we have to do it like that. Okay. Start by doing like that. Okay. From FastAPI import FastAPI, which is weird that you have to do that. Why can't you just say import FastAPI? That's like... libraries can absolutely support that. There's no reason, and they could use the underscore init directory in order to implement Git, and then you're going to specify the route. This is the route when you access the server. Through HTTP, it'll just be the / So this is the root. And then you can define your function def root, which the root. I just said it was root. Yep, root. And then you can just return a string, and you can return JSON. So we could, we'll turn just hello for now. We'll just return hello for now. And that's it. You've made your server. You made the server, and you're good to go. We've added all our venv as well to the Git, which I'm not used to doing this. Neva said we should do it, although there's a lot here. I don't know about this. Here's what I'm going to do. We'll say rm. We're going to start over rm-rf.get init, and then we're going to add a git ignore by .git ignore file, and we're going to copy the .venv because I don't want this to be in my repository. Actually, what we'll do is I've got an idea. This should run. I believe this should work. So we should be able to say python main.py. Well, it ran. It didn't serve anything. So we have to start the server. All right. So where is that? How do we? There's a special command you have to do. Okay. I forgot about that. There's a special command. So you can't just say python main. You have to say FastAPI dev or prod, I suppose, main.py. So this will serve. Okay. Let's see here. Let me see. It looks like, well, we've got a problem already. Oh, it wants us to install some extra stuff here. Okay, let's try it. Let's try that. Okay, so we installed some extra stuff. There we go. We installed a little bit of extra stuff there. So we've got our FastAPI server all ready to go. You just need it somewhere for something breaks. Got it. Okay. So as you can see here on the screen, we've got our API basically set up as far as we needed it to go. So far. And it will serve only the text hello world. So we've already started the server using FastAPI dev main.py. And then you can say curl http :/ 0.0.0.0:8000, because I do believe, let's double check, that was on port 8000, as you can see here on the screen. It says port 8000. Now you might be saying, hey, Steven, hold on a second. It says 127.0.0.1. Why are you putting a whole bunch of zeros in there? Well, because it should also work, as far as because you're accessing your local system. So it should also work, I believe. Let's find out. Curl should say hello. Hey, there you go. Look at that. If you didn't know that you could use a whole bunch of zeros, now you do. And also so you should be able to do the same thing. 127.0.0.1 should also say hello, right? You should also be able to say localhost, which is localhost should be the same thing. There you go. Running your server. Crash. It didn't crash. So let's find out. Let's try curl 0.0.0.8000. And there you go. It works. And we don't probably even need to import JSON. I think we don't even have to. Let's try that. Yep. There you go. Hey, we're making our way. We don't have to do anything. FastAPI makes everything easy. So we got that part going now. So now what if you wanted to add like a whole bunch of different endpoints? So you could copy and paste this, and we'll say this is our natural, what's the NLP, right? Natural language processing. Natural language processing. Is that what is that? Wait, what does NLP stand for? Is that what NLP acronym? What is this? Natural language processing. Yeah, that's what it is. Or neural linguist programming. But in this case, we're doing natural language processing. We're going to see if we're going to have an input, and we're probably going to do a post. So we'll need to do a post here instead. We can do a post. You got it right. Nice. You got it right. We got it right, you guys. -D for data. That should be perfectly fine. So query data location. Field required. Input null. Missing. Interesting. Okay. How about we go this? Data. All right. Then we'll check out the docs really quick. Okay. So let's get into it. I want to do a post. Let's do post FastAPI example. Because we want to be able to input data. Okay. So post. Okay. I'm trying to distill this into a really simple model. Okay, really simple stuff. Keeping it really simple. Let's see here, FastAPI. We'll make this work. We'll make it work. Oh, nice. And curling at the bottom. Yep, you got it. So we got our server code at the top, and then we've got the curling at the bottom. You got it. Simple. Okay. Okay, let's see here. Okay, so we need the body. Okay. So what we need to do is we need to capture the post body. That's what I'm trying to capture right now. We're trying to capture the post body. Let's see here. We're reading the docs here. We're reading the docs. You would think that getting post would be super easy, and it should be. It should be as simple, nearly as simple as doing this, right? I want it to be as simple as that. So I'm reading through the docs to make sure that we get you the simplest possible version, because there's a lot of options that are complex, a lot of complex options, and I want to make sure that we do it. Absolutely do this. Okay, here we go. Item no model. Perfect. Okay. Request. This is what we want. Okay. Now we're into it. Okay. Excellent. So let's grab this. Go back up here. So we're also showing you how to read the docs, right? We're showing you how to read the docs. So we want a request, and then we want to capture the request, which is going to be a request type. Here we go. Request type. Excellent. NLP. Suppose with the / there, and then we got our data, which is going to be a dictionary, and then we're going to turn it into JSON. Okay, perfect. And then data. Let's call it data, and then we'll return data. All right, so this is an echo. This is a simple echo. All right, we made it as clean as possible. There were a lot of options available that required a significant more. We're doing AI API today. So we just created a simple API using FastAPI. I really like clean, small, powerful code using minimal features of the language to keep things simple and our tech debt low. What you're seeing here on the screen is a simple read-only endpoint, and then you see a read-write endpoint with the post. This is, and you can access that by saying curl-x post and then .d. So you can see here with a -d, and then the whatever data you want to transmit it. Whatever data cool stuff. Yeah, I think so too. I think it's really powerful. It is really powerful stuff. You can create your own API. Got the JSON data. Now, press enter. You're good to go. And we just echoed the same data back. So what you could do is you could say just the text data, right? Text, and then it will only echo back the texted data. So you can see that got rid of all the dictionary. So we're reading right into it. I have some AI agents. Would you allow me to use this API? Of course. Of course. Python. Now that we have that, the next step is we want to actually do some natural language processing. This requires us to import extra libraries, and we'll be doing this from Hugging Face to keep things super, super clean and simple. So let's go on to Hugging Face next and get the AI model that we want. Hugging Face models. Let's do text processing. Let's see, natural language processing, text classification. This is what we want right here. Wait, let's zoom in. Let's zoom in on this. All right. We want text classification. Sachin, hi, Steven. Can you please explain what we're doing? Yes. We're making an AI API, which allows businesses or other users on the internet to access your AI, and then you could sell them. You can sell them access to this API. Thank you. Yeah, absolutely. And that's it. It is really simple, which allows a way to enable you to maybe start a business or to create a microservices at your own company or at your job to then access an AI from FastAPI. That's what we're doing. Are you going to add a DB, or is this just the building the API? Oh, right. Kevin McAllister, right. So that's the extra step. If you want to add authentication authorization, allowing you to verify if there's a paying customer or a non-paying customer, you would add a database as well. Our software toolkit for optimizing and deploying deep learning. So it makes it faster, better, and more stable. Is that what we're saying this is? Is that what we're saying this is? GenAI is a new library they made for large language models. So yeah, if you want to go for the large language model where you've got generative AI, then that is going to be another topic, right? So we're going to keep things simple today with using traditional machine learning and deep learning, which of course is what, transformers and, general large language models are based on anyway. It's just that they're much larger and requires more compute power. We want to keep things simple today, maybe even something that can run on a CPU. That's kind of what we're going for today. That's kind of what we're going for. So let me see if we can get some text classification here. And we'll see. We'll just get something going because I want to make sure that we have an end-to-end working example that you can follow along with. Okay. Let's see here. There are a lot of options. Which one do you choose? I don't even know. I want to make sure that we pick the right one. So okay. So here, text classification. Got to click that first. Okay, perfect. Okay. Oh, you got to avoid Hugging Face potentially with which whenever you can. That's nice. Good point. Whenever you can avoid Hugging Face and you can go straight to a very specific model. That would be a good idea. That's a really good idea. We can do that here as well, I believe. I'm just trying. We're trying to keep it simple for today. Multi-language sentiment analysis. This sounds like a good option. Okay. Okay. So let's use this model. We'll zoom in. There's a use this model button here, and you can click on transformers, which is a nice easy option. And you basically just have to copy and paste this right here. And that allows you to easily leverage this model. And it loads from Hugging Face directly. And so it's just sort of like an easy getting started. Now, like Neva is describing in chat, it's a lot easier to build faster and more efficient and more stable systems going direct to the model. And you can do it a different way. You don't have to use Hugging Face. So there's other options. Here's how you'd use the pipe. It's really easy. So this is what we're going to do. We're going to make it really easy. And we won't even use serialization. We're going to simplify it a lot. Okay. So let's import the data. So we also need to open up our requirements file. Requirements. And we're going to do, I believe we need the transformer. Okay. So let's go over here, and it's going to be transformer. So we want to import this library as well. So let's copy and paste that there. Okay, so pip install -r requirements. Let's see. Okay, so it looks like we got everything. I don't know if we need to add more yet. We might need to add like PyTorch and a few other things, right? So Torch and Torch Vision. So we might want to do Torch Vision, right? I think we need to add those as well. So let's go ahead and do that. Let's do that. Hey, Kevin McAllister, once you get the NLP model working and want to do more, if you have Ollama, Ollama, you can probably run a small large language model locally via Python Ollama libraries. that'll return the gen text on the API request directly. You're right. Ollama is a very fast and easy way to set up your own, essentially, chat GPT, right? That you could run locally. You pick the model that you want to run. You can choose any of them, GPT OSS, Mistral, DeepSeek, lots of options. There's a lot of good options out there. And so let's see if we can get started. I'm going to not use these right now and see if that works. All right, we're gonna try this first. We're gonna see if we can get that working. Okay, so we've got our pipeline, our FastAPI like before. Thank you, guys. Thank you for the hearts. Thank you so much. Good to have you here. And then we have our pipe, which will be, we'll say NLP, just to keep it simple. NLP. So that's our NLP pipe. Now let's make sure when we load this, let's see here. Okay, so we need to import. So let's install. Okay, looking good. Okay, so we're installing transformers. So that way we can run this and it should work. It should work now. Maybe. Okay, good. It's working. Okay. It's importing the model, it's loading the model, and it's getting ready for our server. Capture the raw bytes from the body, which is the post body, and then you can decode it to UTF-8. So it converts those bytes into readable ASCII or UTF-8. You could do that if you wanted to. And that's just extra stuff that makes it less flexible going forward. That's why, hey, how's it going, Marwan? Marwan, happy Friday. Today we're doing AI APIs, and we did it from scratch. We did it all from scratch. So you can see here at the top of the screen, we've got our own AI API, and we're going to make sure that we're going to make sure that we do it end to end, and it's going to work. We're going to make sure that it absolutely, we're going to make sure that by the end of today, we will have a fully working AI API. It's going to be using traditional AI, so it can run on your local system without additional hardware acceleration. And we're going to do natural language processing, which is going to give you a sentiment on the text, which you can do. You can use this information to capture headlines on the news. And then you can also, so here's our data. We've captured it from the post. As you can see, we're doing an echo. So now let's do text equals data text like that. And then we're going to say sentiment or sent. Is this how you say sentiment? Let's double check. That. I'm going to copy this line right here, and I'm going to paste it. No, not Venmo. Sentiment. Yeah, we spelled it correctly. All right, but good. We spelled it correctly. Okay. Sentiment equals NLP text. There we go. And then we're going to return sentiment. There we go. Text classification. There we go. Thank you for the likes, you guys. Hey, John Moore. How's it going? I just went through this for Julia and Bert transformers. Had to build the API for text classification, clustering, and so on. Yep, there you go. John Moore, that's what we're doing today. And as you can see on the screen, everything above, the halfway point, that's all the text we had to write. We didn't have to write anything else. Isn't that amazing? Isn't that amazing how little code you have to write to get something up and running that is pretty close to production grade? Now there's extra stuff that you want to add for production. You want observability. You want to have auto recovery. You want redundancy. There's a whole bunch of things you can do there to make your API more stable. Hardware can fail, networks can fail, things like that. For this today, we're just going to cover just building the API. That's what we're doing. Another one can just plug in Anthropic or OpenAI API. Yeah, you could do that too. You absolutely could. So if you wanted to, you can wrap those APIs with your own now. So then if you wanted to, you could say like import OpenAI, and then you could use OpenAI and then wrap that and then make it your own. So if you wanted to build an AI agent, you could then use this approach that we just did here, and it will allow you to sell your agent. And they won't know that you're using OpenAI API. They won't know that you're using Anthropic, and probably you use both, because if one fails, you can try the other, and that can add redundancy. You can do it that way as well. That's actually a really good business idea. You got there. I like that one. That way we can improve the performance and we don't block anything. And we can start that probably with UVcorn, right? UVcorn will give you the ability to launch multiple instances of your API. So that way you don't have to block concurrent users accessing your AI. LangChain with Ollama is fun. Yeah, we could do that too. There you go. There's another way to do it. There's so many options. It's fantastic. Like if you try to catch a crashes, might not allow you to use PyTorch. Ah, got it. Got it. All right. So there's a lot of things to watch out for. Obviously, you see here, like Neva is describing, we don't have any try catches anywhere. So if we're going to try this right here, like this line could fail. So we should probably wrap this with a try catch. I do believe is going to be negative, or is going to be like a negative sentiment. And then 1, all the way up to 1 will be a positive sentiment. There you go. All right. Open up the requirements. And then we say like that down the middle. All right. So as you can see here, we did very good. We did very good. Here's the dependencies. And here is all the code over here. 100% of the code. That's it. Right there. 18 lines. And we did it. You can very easily build your own AI API using Python and this approach that you see on the screen. Python with FastAPI and Transformers API to get whatever model you want to run. There you go. So easy, so clean. It works. There's some good info in that. Before we do that, let's double check. So you might want to add a try except. So you could do a try except here. So you could do a try, and then you could say except, and then you could return an error or return the sentiment. So for example, let's go ahead and save that. Actually, what we have to do is we have to get rid of this really quick. Okay, let's save that. And then I decided to write a guide to make stable AI code in Python. Oh, nice, Neva. That's really grateful. That's actually really great because I realize it's actually not easy to not be screwed by Python. You're right. There's a challenge in there. You can easily get overwhelmed. There could be imports in modules and packages that have dependencies, and there's conflicts. There's a whole bunch of problems that can occur. You're absolutely right. All right, so if we curl this, natural language score looks good. Oh, let's try something. Let's try something. Darn, sad, bad. All right, so that should have a negative sentiment, right? Or low. Oh, well, it is. Okay, negative. All right, so there you go. Neutral, negative, neutral, and let's add a positive one. All right, so let's add positive. Happy, joy, win, alive. All right, positive. There you go. Positive, negative, neutral. There you go. There you go. Isn't that great? You've just created your very own AI API in a few lines of code. Make it really simple. Make it really simple. Now, obviously, if you do a syntax error and you forget something, you want to return an error. And so there you go. There you go. That's why we added the try except just now. That's why we added the try except right there. And that's because of Neva. Neva, thank you. Let's see. Like it happens usually, stuff breaks. Yep, it does. It's unstable. And you think you're good, and then it breaks, and you spend hours and hours to repair it. Yep, PTSD core. You got it. Cool, isn't it? Isn't it neat? And that's all the code. That's 100% of the code right there on the screen. Right here, all of it. You're looking at all the code. There you go. Isn't it great? I think it's great. Such a simple, so clean, so easy, very simple. I love it. I love it. How many requests do you think it'll take? Crash? Oh, before FastAPI, do you think multiple bash and while loops will crash it? It will show you how to benchmark it. Okay, this will be the last thing we do. We're going to benchmark the servers, one of the testing procedures that you do for production readiness on your AI API or any API. Are you guys ready? We're going to benchmark it. We're going to stress test it. This is like smoke testing almost. So you could, let's do, this is the naive version. So while true, true. So this is an unlimited loop, true, right? Do curl, and then you probably want to say echo, and then done, right? So do that. So this will put it in a tight loop. So as you can see here, it's pretty fast. That's a lot of requests per second. We're doing pretty good here. That's quite a few. That's quite a few requests per second, as you can see here on the screen. It's going pretty fast. That's actually pretty good, right? And that's for a single process. That's a single process. All right. Let's see. So that's like a naive benchmark, and it does pretty good. You could probably, do higher concurrency on that if you wanted to. You could do more concurrency. So yeah, so we benchmarked it really well, and then we kind of would also like to see here. Let's open up a htop. All right. Let's see what the CPU looks like. Yeah, we're not even stressing the CPU that much. You're not even stressing the CPU. It looks perfectly fine. We're looking, oh, rate limit is a good thing. You could also do rate limiting if you wanted, or you could just have it go as fast as it possibly can. You can absolutely do a new terminal and run the same thing again. Okay, are you ready? All right, here, we'll make it happen. We'll do it. All right, so here is all right, here we go. 2 terminal windows doing the exact same thing. Are you guys ready? Here we go. Boom and boom. There you go. And as you can see, it's still running perfectly fast. It's still running. You can build, and that's FastAPI, and that's, I believe, as far as I can tell, you know what? Let's see if it is running on. So let's do activity monitor. I'm going to open this up to see, is it running on my GPU? It is. Okay, so we are doing GPU computation as well. So that's why it's fast. You can see here the blue bar. The blue bar says it is running on GPU. This is, yes, this is Apache Bench. Okay, so we're gonna go a step further. I have Apache Bench installed. Thank you for the likes, you guys. Thank you for the heart icons and see the floating icons in there. All right, so Kevin McAllister, we did a very simple benchmarking using curl in a tight while loop in 2 different terminal windows. So now we're gonna use Apache Bench, http://0.0.0.0. You know what? Actually, let's grab this curl really quick. I want to do this. Let's see. So we can. Let's see. How do we? Let's look this up real quick because I forgot the syntax. So we do AB Apache Bench post example. All right. Let's do a post example of the Apache Bench, which is just a easy way. Okay. So .p JSON data. Okay. T application JSON. We don't need the T. Okay, perfect. So this will see, this is gonna actually benchmark it a little bit better. This will benchmark it just a smidgen more. Okay. So let's paste that in, and this is gonna be, what was that? 0.0.0.0:8000 /NLP. And then we're going to, we need to add in the post data. So we'll add that in. So we'll create a post data file. We'll do that. We'll create a data JSON file. So where is that at? Here, I'm going to copy this. Here we go. We're going to copy that. And we're going to say echo that into data.json. All right. Now we're going to run AB with 100 requests at 10 concurrent requests. So that means 10 requests simultaneously. That's what we're going to do. 10 requests simultaneously. There we go. And that did it. And we did 100. Let's do more. I'll benchmark it for more. So let's do 10,000 requests. 10,000 concurrent. Okay. There it goes. 10,000 requests. And it's going to tell us how fast it was. Just with FastAPI, no UV corn, just a simple dev server, even in dev mode. So it's not that performant. If you don't hide variables, is that why Python struggles with dispatch, parallel distribution, and so on? Python has, global lock interpreter. It prevents you from doing common concurrency. It does offer threading, which you can do. Though from a concurrency perspective, the CPU, you can't really do multiple CPUs unless you use something like multiprocessing, which is what UV corn is. It's going to split or fork your application into multiple processes that can run concurrently on the machine, and then it's going to be routing requests to each of those processes. So there you go. Although if you have limitations on your GPU, that's another limitation, right? There you go. Yeah, that's a good point, Kevin McAllister, since it's using the GPU. I'm actually surprised you can stream this and do it without lag. We got a good computer. Isn't it amazing? So we are benchmarking and we're live streaming all at the same time, and it's using the GPU. We're doing pretty good. All right, let's also open up here. Let's open up, let's see, we'll close this, close that window, and we'll open up HTOP really quick. So you can see, we can see it benchmarking. There you go. You can see the benchmark. And as you can see, it's hitting it. It's definitely hitting it. We could go faster though. It looks like it can take more. All right, let's do more. Let's do 100 concurrent requests. Let's 10x this. We're gonna go 10x more. There we go. 10x more. And it is bumping it up just ever so slightly. It seems perfectly fine, doesn't it? I believe we're hitting not a CPU bottleneck, but a GPU bottleneck. We're hitting the GPU activity monitor. So if we pull this up, let's see what our GPU is doing right here. We'll see what the GPU is doing. Let's see here. Let me click this button. View, always on top. There we go. Okay. The newer Python version, they changed how the global interpreter lock works. 173 per second on a system like a consumer hardware. That's pretty good. We're doing pretty good on consumer hardware. That's pretty good. because it's very hard to write C code that works with no GIL in Python. Yeah. Oh, got it. So most of Python is all C, right? Python is all C. And the libraries that you import usually are also written in C for performance reasons, right? For performance reasons. So we're also running, by the way, we're running dev server. This is dev, FastAPI. You could do it let's see, FastAPI. Let's see if we can dash help. How do we do prod? So there's dev, run, deploy, login. Okay, so FastAPI, run, main. All right, let's try that. We'll do this again, main.py. Okay, so this is performance mode. This is performance mode. So let's see what it looks like in performance. Let's try this again in performance mode. Let's see if we get anything better. I don't think so, because I believe our bottleneck is going to be the GPU. The bottleneck is the GPU. Like PyTorch requires the GIL. It does, yeah. It would be. I understand that. And it's fine. It's perfectly fine. You can still get concurrency with Python by using multiprocessing. It splits your Python into multiple system processes. Now your OS will manage the concurrency, essentially, and the share of CPU time that's gated across all of your processes. So if you've got multiple cores on your CPU, you're good to go. It'll concurrently process things generously for you, no problem. You can also use UV-corn here, and that's what we could do. So what did we improve it by setting it to? So we saw a couple of extras. So we got a few more requests per second, which isn't all that great. It's not all that great. Now, that's because of the AI. What does it look like when we don't use the AI? All right, let's try this. Let's try not using the AI. So here we go. This is what it looks like with just standard request response. Thank you for the likes, you guys. Oh, whoa. What? Oh, wait, did it work? Wait, dash. Okay, so we don't need this. Let's get rid of that. Okay. That should work. Why is that not working? Oh, wait, /? Okay, /. Maybe it wants that. Let's see here. Delete. Done. Okay, there we go. Wow, look at that. That was a lot faster, wasn't it? So our GPU was the limit. Now you can see 700 versus 5,000, right? Isn't that a lot faster? 5,000 is a lot faster. So now that tells you that your bottleneck is on the GPU side. There you go. So what you could do next is, spin up a bigger GPU system, use multiple GPUs, use a faster GPU, and then you'd be able to accomplish what a standard system would be able to do. And you could go even further. You could do UV-corn. So we could do UV-corn, and I think it'll go even faster. So let's see if we could do that. Can we do UV-corn? I think we have to install it. I think we install UV-corn. That Python is basically glue code with all the C. It is, yeah, it's all C. You're right. You're absolutely right. It's glue code. If you want Miller, you probably want Mojo. Mojo. But like all the useful libs are going to be Python, right? C Python. Yep, exactly. C Python. That's why it's faster. That's true. Yep. Basically glue code. Yep. The Python's actually, it's actually all just C. It's all C behind the scenes. Julie has a lot of dynamic calls. Neva. Oh, got it. Julia plus MLIR. All right. Sorry. I was doing my something. I'm back. You're back now. Okay. Yeah, legendary. Sounds good. Oh, Blue. Hey, Blue. How's it going? I missed your chat message over there. Steven, it's been so long. I've been busy with college. Love how you're so consistent with your streams. Hey, that's right. Once a day. We'll do live once a day. It's great to have everyone here. This is awesome. It's a really good Friday. So happy to have you all here. Fascinating. Can you scale with the cloud though? Oh, you absolutely can, right? Because now you've got more CPUs. No, Eddie, you stole my spotlight. I know, Kevin. You stole the spotlight. Hello, everyone. Arajit. Good to see you. Sorry, I've got multiple chat windows over here, so I want to make sure I capture everyone's chat. Miller is pretty interesting, although Clang is already slow compile. This is throwing gasoline on that. Oh, is it? So you get even faster. All right, I want to see how we can get UV-corn up and running. Let's get UV-corn running. All right, let's go here. Let's see, L. UV-corn with FastAPI. Let's see. Let's get that up and running. So we need to install it. Let's do this. Okay. So that's the standard, but I want UV-corn. Okay, here we go. So UV-corn. UVcorn. Do we need to install it though? Is it already available to us? Let's see here. UVcorn. Let's see here. UVcorn. Yes, we already have it. All right, it already comes. We already got it. We already have UVcorn. We're good to go. All the libraries are good. Now we're going to go in production mode. Okay, we're going to go in production mode. Okay, so UVcorn, and then let's see, main.py. I wonder if we could do that. Let's see. Reload flags, auto reloading. We don't need auto reloading. App refers to the FastAPI. Okay. Okay, good. Okay. Main app. Okay, perfect. Okay. We're good to go. I think LLVM might be some without. Oh wait, LLVM. There is a version where you can leverage if you're using large language models and you're running them locally. There is a what is it called? Flash embedding, which captures essentially it's a mega kernel. It captures multiple steps from GPU acceleration into a single GPU kernel, which gives you a lot fast, because a lot of the I/O input and output between the CPU memory, the system memory, and the GPU memory is the bottleneck. So if you're doing that, that would also work very well. The dynamic code is made in a dialect, then it's fast. It's faster in C. You got it. I started a war. Mike was UVcorn. I believe it is main. Was it app? Let's double check. Main app. Okay, perfect. Main app. Okay, we should be able to run that. Now, this will boot it up, and it's going to give us more performance. So we're going to use multiple CPU cores and all of our GPU. So this should be really fast. Okay, so let's redo the AB. Okay, let's see how fast this is. All right, is it, where do we get? Twice as fast. Wow, 11,000 requests per second. And so there you go. Now you can build your own production grade, high scale, high performant AI API. You absolutely can do that. Isn't that great? So we got about 300 per second. So we did 300. So we boosted it. A bit. So now we know our bottleneck is the GPU. And they just needed a bigger GPU. And you're good to go. That's it. Wait, what codes and stuff are you doing? I'm so confused. Oh, thermal man. Okay, so we built, let's just open a new window here, ls vi main, a very simple AI API. Here, all the code's right here. And then there's also a dependency file right here called requirements.txt with all the libraries. Only 2 libraries we had to import. Now you have your own AI API that you can deploy into production, and it's a high scale, right? And so let's see here. readme.md. Let's add the instructions. So we're going to say, you want to say pip install -r requirements, and then you want to say uvcorn, uvcorn. Let's type that right. Main, and then no reload. You don't want reload. All right, so for production. All right, production deploy, right? 1, 2, 3. What did you program exactly? Okay, Basti Fantas, we built exactly, let's see here. Let's see. All right, so let's walk through the code really quick. So here's the code, top to bottom. Very simple and clean and easy. Everything you see on the screen is what we wrote live here right now. Completely empty file. It's an API that can serve AI responses. The example that we gave was natural language processing, and it will give you the ability to sell the API to anyone that you want to sell it to, and it will return a response giving a positive or negative or neutral sentiment. That's exactly what we wrote. You can go a step further. You can add in different AIs. You don't need to do this one alone. You can basically import any AI that you want and then surface it like that. And then you could sell it to anyone you want. There you go. You can start a business. You can start your own business. You built your own AI from scratch, or your own API from scratch that is able to serve AI responses. And then you can host this on any of the cloud vendors. You could do Amazon, you could do Google, you could go Azure and Microsoft, you could do Cloudflare. Wherever you want to go, you could host this, and you're good to go. And it's very fast too. We even include benchmarking. We did benchmarking, as you can see here. Let's do the benchmarking. There you go, a whole bunch of requests. And It's so fast in production mode, almost 12,000 requests per second. Way more than you need. You don't need any more than that.